Okay, today we're going to be factoring trinomials with a leading coefficient of 1. And so we're going to keep following the same steps that we've been following. I'm going to put them up here at the top of the page. The first step in any factoring problem is to look for a greatest common factor. And if you have one, you factor it out. Then our second step is to always ask ourselves how many terms. And we have done ones that are 4 terms, and we factored those by grouping. So today we're going to do 3 terms that have a 1x squared. So in other words, that's what it's talking about when it says leading coefficient of 1, you have a 1x squared. And again, we're going to have to make sure that they're in descending order and things like that. So in order to factor the 1x squared, what we're going to do is we're going to find factors of the last term that add up to the middle term. And I like to make a list when I do these. So I go through here and I'll look and I'll say, okay, I see a factoring problem. Do I have a GCF? So I've got x squared minus 10x plus 21. There is not a greatest common factor to take out. I've got how many terms? And I've got 3, and I have a 1x squared. So that means I'm going to find factors of 21 that add up to a negative 10. So I just make a list. 1 times 21 is 21. 3 times 7 is 21. And those are the only factors of 21. To get a positive 21, I could use 1 and 21, 3 and 7. But that's neither one of these are adding up to a negative 10. So I have to think about what are other factors that I could multiply to get a positive 21. Well, if I have 2 negatives, so negative 1 times negative 21, that multiplies to get me a positive 21. Still doesn't add up to negative 10, but it multiplies. My other option would be negative 7 times negative 3. Those multiply to get me a positive 21, but they add to get a negative 10. So there is my correct combination. Now, to write the answer for these trinomials, make you 2 parentheses. They're going to have binomials in them. Your x squared gets split up into x times x, and then your factors that you found in your list that work, minus 7 and minus 3, go in the parentheses. And there you go. There's my answer. So we can find factors of the last term that add up to the middle, make a list to do that. It's very helpful to make that list. So since multiplication is commutative, a factorization of a plus b, c plus d could also be written as c plus d and a plus b. What that means is that that answer that I wrote above here, x plus 7 and x minus 7, x minus 3. I could have written it x minus 3, x minus 7. And it's still the exact same answer. Now, how can you check these? You could FOIL that back and check it and make sure you get x squared minus 10x plus 21 when you FOIL it. Okay, let's keep going. The more we do, the easier it gets. While I'm thinking about it, on this page, if you have a matching page and you're following along, this there's a mistake on this page. The negative 2 times negative 6 was the right combination, and then they came down here and wrote the wrong number. That should be a minus 6 right there. And so this should be a p minus 6 in there. They found the right combination right here. They just wrote the wrong number when they wrote it down at the bottom. So I didn't want that to confuse you. Okay, so let's move over here to t squared minus 9t plus 18. Do I have a GCF? No, I can't take anything out of all 3 terms. How many? I have 3, and I have a 1t squared. So I'm going to take 18, and I'm going to find factors. So 1 times 18, 2 times 9, 3 times 6, 4 doesn't go into it, 5 doesn't go into it, 6 would be repeating. Okay, now I'm trying to get a negative 9 in the middle, so I know I've got to put some negative ones in here. So negative 1 times negative 18, negative 2 times negative 9, negative 3 times negative 6. The negative 3 and negative 6, those are the ones that add up to a negative 9. So I come over here and I make my parentheses. I split my t squared up into t times t, and I have a minus 3 and a minus 6. There we go. Now, those are ones that are very straightforward. Look at the one at the bottom of this page. And remember, what is our first step? Our first step is to always look for a greatest common factor. So on this one, yes, I have a greatest common factor. 100 will go into each of those. Do I have a t in each one? Yes, I do. The smallest exponent of my t's is a t squared. So I'm going to take out a 100 t squared first. And that's going to leave me t squared minus 8t minus 33. Okay, so this is part of factoring completely. We did the first step. Now we need to look at what we have in the parentheses and see if we can break it down further. So I need to find out if I have factors of negative 33 that add up to a negative 8. So to get a negative number, one of our numbers must be negative. So 1 times a negative 33 or a negative 1 times a positive 33. Those would both multiply to get me negative 33. I could use 3 times 11, a negative 3 times a positive 11, or a positive 11, or sorry, negative 11 times a positive 3. Now, the negative 11, positive 3, that's the one that adds up to the negative 8. The other ones didn't add up to a negative 8. This is the right combination, negative 11, positive 3. So then I come down here and I've got t minus 11, t plus 3, and then don't forget we took out 100 t squared at the beginning. So there's the final answer on that one. Okay, let's look at the next page. The more we do, the easier they get. Alright, well, 4m cubed minus 12m squared minus 60m. I could take out the GCF of a 4 out of all of those and an m. So let's do that. 4m. So that's going to give me m squared minus 4 goes into 12 3 times with an m left over, minus 4 goes into 160 40 times. Okay? So the 4m is going to go in our final answer. Let's look at what's in the parentheses. Do we have any factors of negative 40 that add up to a negative 3? Well, the first factors, and you know I've been listing factors 1 times 40, 2 times 20, things like that. But if you might start being able to recognize factors that might give you a combination of 3. I know that 8 times 5 is 40. So to get a negative 40, I'd have a negative 8, positive 5, positive 8, negative 5. Do either one of those add up to a negative 3? Well, that first one that I listed adds up to a negative 3. So then I come over here and I put m minus 8, m plus 5, and then I took out a 4m at the beginning, so I need to include that in my final answer. Now, what if they're not in descending order? Remember, all factoring problems need to be in descending order. So this next problem is not in descending order. So let's write it in descending order. I've got a negative m squared, negative because there's a negative in front of it, plus 16m minus 15. Now, you cannot factor this problem with that negative in the very front with the m squared because it's the parentheses, it's just going to be very difficult. So the best thing to do is to take out, I'm going to call it a GCF, but we're really just dividing out a negative 1 since there's no other number in front of that m. I'm going to take out a negative 1, and so that's going to change these signs. M squared minus 16m plus 15. And we're going to find factors now of 15 that could add up to a negative 16. Well, I know 3 and 5 aren't going to work because there's no way I can get a 16 from a 3 and a 5. I've got a 1 times a 15. That gets me a positive 16. But if I took a negative 1 times a negative 15, I'm still getting a positive 15 when I multiply, but when I add them, I get the negative 16. So then that gives me m minus 1, m minus 15, and I took that negative 1 out in the very beginning. You can just put a negative in front. You don't have to write the 1. You can just put a negative right there with it. Now let's try one more like that down at the bottom of the page. This is not written in descending order, so I'm going to go ahead and do that. Negative z squared plus 11z minus 28. So let's take out that negative 1 and have z squared minus 11z plus 28. Now I'm looking at factors of 28. 1 and 28 don't work. I know 7 times 4 is 28. That gets me positive 11. I need a negative 11 though. Negative 7 times negative 4 multiplies to get me a positive 28, adds to get me negative 11. So I'm going to have z minus 7, z minus 4 with a negative in front because I took that out in the beginning. Okay, let's do some that have more than one variable. These are sometimes confusing because you're trying to find, trying to put variables in different places, and they just can be confusing. So the first of all, we need to look, do we have a GCF? Because always look for a GCF first in every problem. Here, I can't take out an x from all three because this 20 doesn't have an x with it. Can't take a y from all three. There's no number. So now I just go straight to my numbers. Let's just concentrate on the numbers. I have how many terms? I have 3 terms, and I have a 1x squared. So I know I'm using my same method. So I need to find, I'm just looking at the numbers, 20. I need to have factors that multiply to get me negative 20, add to get me 8. So 5 and 4, that's my numbers that I think of right off that multiply to get 20. But neither one of those, when I set up my signs to get a negative 20, they don't add up to an 8. So let's try 10 and 2. A negative 10 and a positive 2, that gives me a negative 8. How about a positive 10 and a negative 2? That multiplies to get me negative 20. 10 times negative 2 is negative 20. Adds to get me a positive 8. So I know that's correct. So here's how you do these ones that have the 2 variables that you couldn't take out of GCF. Remember, we're making 2 parentheses, 2 binomial parentheses. And my x squared always gets split up into x times x. Well, this time, since I have a y squared at the end, we're going to put a y at the end of each parentheses. And then my number combination just goes in front of that y. So plus 10y minus 2y. And if we FOIL that back, we'll end up with that 8xy in the middle. Now let's try one more like that. S squared minus st minus 20t squared. There is no descending order there because I have an s squared and a t squared. I can't take out a GCF. So, and I have a 1s squared. So I'm looking for factors of negative 20. Well, I've got 10 and 2. I need a negative 20. That's not helping me. Neither one of those add up to a negative 1 is what I'm looking for. There's an imaginary 1 there. Alright, let's try 5 times 4. So negative 5 times positive 4, positive 5 times negative 4. The negative 5 plus 4, that adds up to a negative 1 when I add those together. So this is my right combination. So I'm going to make my parentheses. This time I have an S, so S and S. I have a T at the end, so T and a T. And my factors were minus 5, so I have a minus 5t and a plus 4t. And there's the right combination. Okay, let's look at the next one. Notice it says identifying a prime polynomial. So sometimes maybe there's not a combination that works. Let's see, we've got x squared plus 6x minus 8. There's no GCF. I've got 3 terms. And I have a 1x squared. So I'm looking for factors of negative 8. Okay, so that I start off with 1 times 8. One of those has to be negative. So negative 1 and 8, 1 and negative 8. Okay, those add up to 7 and negative 7. I'm looking for a 6. So I move on to 2 times 4. Negative 2 times a positive 4, positive 2 times a negative 4. This gives me 2, this gives me negative 2. I'm looking for a 6. Are there any other factors of 8? I cannot think of any. There are not any other factors of 8. So once you have made a complete list, do not just say that a problem is prime if you haven't made a complete list. Make a complete list. And no factors work. then we can say this problem is prime. But I only do that if you make a complete list and you can't find any other factors. Let's do one more like that. So at the top, this little definition sentence: when factoring a polynomial x squared minus bx plus c, we must find factors with a product of c, that's the product of the last term, that add up to the middle term, which would be b. If no such factors exist, then the polynomial is prime. Prime does not happen very often. I'm just telling you, most of the time you can find the combination. So here I'm looking at s squared minus 7s minus 20. There is not a GCF, 3 terms, so I'm looking for, and I have a 1s squared, so negative 20. So 1 times negative 20, negative 1 times 20. I'm looking for a negative 7. 2 times 10, one of those has to be negative. 2 times negative 10. That doesn't give me a 7, negative 7. 4 times 5, something has to be negative. Neither one of those are giving me negative 7, and this is my entire list of 20. So none of them are adding up to negative 7, so I can say that this one is prime as well. And again, that will not happen very often. Most of the time you're going to be able to find an answer. Alright, that's all with factoring trinomials that have a 1x squared. Y'all have a wonderful rest of the day.